here we are given three lines PA, QB, RC, all of them perpendicular to the same line AC, or in other words all of them making 90 degrees with the same line AC. What does that mean? It is not just about 90 degrees, any angle, say for example three lines, all of them making the angle say 30 degrees, randomly 30 degrees, but making 30 degrees with the same line AC. What does that mean? It means that all the three lines are parallel. Why is that? If you consider AC as the transversal, what you have is equal corresponding angles. So that means all the three are parallel to each other. Here it is 30 degrees. It is the same for 90 degrees. All the three of them perpendicular to the same line, which means all of them are parallel to one another. And what we need is to get a relation between X, Y and Z, which is the measure, which is the length of these three lines, and we need to get such a relation between them. And how do we do that? We will take two at a time. First we will forget about this line, this AP line, we will forget about this. We will just consider these two lines. We will construct two similar triangles, and at that time you will need these two sides also. I will name them A and B. We will get a relation between Y and Z, and in the second step we will forget about this and we will get a relation between X and Y. So shall we start? So now here we have two triangles. First is this small triangle QBA, and the second one is this whole triangle, whatever you see here, that whole triangle. What we are going to prove is that they two are similar. And what is the first thing you notice? Both of them have the common angle A. If this is 1 and this is 2, then what do we know? Angle 1 is equal to angle 2, and both of them are 90 degrees. Why is that? Because we have here that QB and RC are both perpendicular to this line AC. So this is a 90 degrees, this is a 90 degrees. So we have got what? Two equal corresponding angles. So here we have got two equal angles, which means the two triangles, this small triangle 1 and the bigger triangle are both similar. But when you write the similarity, the name of the triangles, be very careful. The names of the vertices of the equal angles should come in the corresponding place. So here A and A are equal, B and C are equal, so where you see B you put C. Q and R are equal, which means where you see Q you put R. This is the name of the two similar triangles, which means what? Their corresponding sides, the ratio of the corresponding sides will be equal, which means what? The first side here, the first side here, second side here, the second side here, and the third side here and the third side here, they are all equal. Now, which all are we concerned about? We are concerned about QB, this one, and we are concerned about CR, this ratio. And what is the side which is going to connect both of them? It is this side, the one with A and B. So these two ratios are the only ones we want. We can get rid of this one. So what is AB? It is A. What is AC? It is A plus B. And what is BQ? It is Y. CR Z. So therefore Y by Z is equal to A plus A by A plus B. This is the first result that we got. Now we have got a relation between Y and Z. So now we can get rid of this and find a relation between X and Y and combine both the results. And how are we going to do it this time? Now we will consider this smaller triangle. I will name this as 1, and this whole triangle I will name this as 2. So how are we going to prove their similarity? The first thing you should notice is what? This small triangle and this big triangle here have the common angle C. Both of them have C in them. That is one of the vertices. So that angle is same. Then what? Both of these angles, angle A belonging to the bigger triangle, angle B belonging to the smaller triangle, are both 90 degrees, because it is given here. You got two of them, two of the equal angles. Then by AA criterion, what do you have? Both the triangles are what? They are similar. Once they are similar, what follows? The ratio of the corresponding sides are same. So let us write down the corresponding sides, and we will take only what we need from here. What do we need? We need X, which is what? PA. So where do we see a PA? It is here. And we need a QB, which is Y. This one is what we are talking about. And next, to connect both the results, we need A and B also. Where do you see them? Here. This one is what we need. The third one we don't need. So I will get rid of this. So BC is what? It is B. AC is what? It is A plus B. So the result we are looking for looks like this. Now let us combine both 1 and 2 and see what we get. Now these are the two equations that we have got. From these two equations, how do we get the result? What do we have to do? We have to get rid of A and B. How do we do that? In both the RHS, you will notice that the denominators are same. It is A plus B. And on the numerator, we have an A here and a B here. So what do? When we add both of these equations, you will see that the numerator and the denominator of the RHS will become same. The whole of the RHS reduces to a very simple one. What happens in your LHS? Again, do you notice that both of them have the same numerator? Let us take that out. And how does that term look like now? Here, there. Then what do? All we have to do is just cross multiply, bring it over here, and there we have our result. So that is all for today. Assalamu alaikum.